Hello, everyone. I'm Lee Hong Mei from number 3 Vocational Technical School of Nanning. Welcome to this mini lecture. In this lesson, we will study 4.1 Transmission Media. This mini lecture consists of 4 main parts. 1. Twisted pair cables. 2. Coaxial cables. 3. Optical fibers. 4. Wireless transmission media. The teaching objectives of this mini lecture are: 1. To understand the types of transmission media and their characteristics. 2. To understand the manufacturing and connection methods of optical fibers. 3. To be able to fabricate twisted pair cables with high quality. Let's begin by understanding what transmission media are. Transmission media are the physical pathway between the sender and receiver in a communication network. The transmission media used in computer networks can be divided into 2 main categories: wired and wireless. Wired transmission media mainly include twisted pair cables, coaxial cables, and optical fibers. Wireless transmission media includes radio waves, microwaves, and infrared. The characteristics of transmission media, including physical characteristics, transmission characteristics, connectivity, geographic range, anti-interference, and cost factors, greatly affect the quality of network data communication. For example, when selecting network cabling for an office, we may need to consider the type, cost, and interference resistance of twisted pair cables. When building long-distance communication links, we might consider using optical fibers or coaxial cables, while in places requiring flexible deployment of network access points, wireless technology may be a better choice. Now let's learn the first part: twisted pair cables. Twisted pair cables consist of 2 insulated copper conductors, typically insulated with plastic to protect the wires from external environmental influences and to ensure electrical isolation between them. The characteristic feature of twisted pair cables is that these 2 insulated copper wires are tightly twisted together at a specific pitch, not randomly but following particular twisting technical specifications. The purpose of this twisting is to reduce electromagnetic radiation and external electromagnetic interference, thereby enhancing the signal transmission quality. Additionally, twisted pair cables offer excellent flexibility and ease of installation, making them widely used in local area network cabling, telephone lines, and some short-distance communications. When constructing a wired network, the combination of twisted pair cables and RJ45 connectors is central to data transmission. An RJ45 connector, a plug with a locking mechanism, ensures a stable connection for Ethernet and telephone lines. According to the T568A or T568B standards, the 8 wires are arranged in an orderly fashion within the RJ45 connector, and the color-coded wire pairs, orange orange-white, blue blue-white, green green-white, brown brown-white, facilitate identification and connection. In practical applications, we encounter 2 types of patch cables: crossover cables and straight-through cables. Crossover cable, also known as a rollover cable, it involves arranging the wires according to the T568A standard at one end and the T568B standard at the other end, then securing them with RJ45 connectors. Straight-through cable, also called a straight cable or standard cable, it uses the T568B wiring standard at both ends, ensuring that both ends have the same wiring order. Straight-through cables are used to connect different devices, while crossover cables are used to connect devices of the same type. Making an RJ45 connector is a technical task requiring precision and meticulous operation, ensuring the physical integrity and signal transmission stability of the network connection. This includes stripping the outer insulation of the twisted pair cable, arranging the wires in the order specified by the T568 standard, trimming the wires evenly, inserting and crimping the RJ45 connector, and testing with a network tester. Precision in this process is crucial. Whether it's a straight-through or crossover cable, correct wiring order and tight contact are key. Through these steps, we lay the foundation for building an efficient and stable network environment. Next, let's study the second part, coaxial cables. Coaxial cable is a type of electrical and signal transmission wire generally composed of 4 layers of materials. The innermost layer is a conductive copper wire, surrounded by a layer of plastic insulation. Outside the insulator is a thin, mesh-like conductor, typically copper or an alloy, followed by an outer layer of insulating material serving as the sheath. Compared to twisted pair cables, coaxial cables offer longer transmission distances and higher bandwidth, but typically at a higher cost. Next, let's move on to the third part, optical fibers. Optical fiber, short for optical waveguide fiber, consists of silica glass fibers capable of conducting light waves, encased in a protective layer, as shown in the figure. It features lightweight and thin diameter compared to metal wires. When transmitting electrical signals using optical fibers, the signals are first converted into optical signals at the transmitting end and then back into electrical signals by a photodetector at the receiving end. In computer networks, 2 fibers, one for sending and one for receiving, comprise the transmission system. Depending on the transmission model, optical fibers are primarily divided into 2 types: single-mode fibers and multimode fibers. Single-mode fibers have a very thin central core that allows only a single mode of light wave transmission, reducing signal dispersion and significantly enhancing bandwidth and transmission distance. They are suitable for long-distance, high-capacity data transmission in metropolitan and wide-area networks used by telecommunications operators. Multimode fibers have a thicker central core that permits multiple modes of light wave transmission simultaneously, making them appropriate for short-distance transmissions in local area networks and data centers. Their bandwidth and transmission distance are relatively limited, but they are less expensive and easier to install. The choice between single-mode or multimode fibers should be made based on network scale, transmission distance, bandwidth requirements, and cost considerations. The connection of optical fibers is usually accomplished through fusion splicing, a process that requires specialized equipment and skill. It typically involves 6 steps. Step 1. Power on and sleeve the fiber. Step 2. Strip and clean the fiber. Step 3. Cut the fiber. Step 4. Properly place the fiber. Step 5. Splice the fibers. Step 6. Properly add a protective sleeve. Finally, we learn about the fourth part, wireless transmission media. In terms of wireless transmission media, we have technologies such as radio waves, microwaves, and infrared. The advantage of wireless transmission media is that they do not require physical lines and can conveniently transmit signals between different buildings. However, they are also susceptible to environmental factors such as fog, rain, and lightning. Microwaves, relatively speaking, are less sensitive to general fog and rain. Now, let's summarize this lesson. In this lesson, we learned about the classification of transmission media, wired and wireless, the types and characteristics of transmission media, the fabrication and connection methods of twisted pair cables, and the fabrication and connection methods of optical fibers. Finally, to reinforce what you have learned, I have prepared some exercises for you to complete after class. I hope each of you will diligently complete them and internalize what you have learned. That concludes this mini lecture. Thank you, everyone.